Have you ever wondered what makes your computer function the way it does? What is the mastermind behind all those applications, files, and processes? Well, let's unravel this mystery together. Picture an orchestra with each musician playing their part, but who's the conductor? That's where the operating system comes in. It's the maestro of your computer, coordinating all the hardware and software, ensuring they play in harmony. It's the silent hero that enables you to seamlessly switch between a document you're writing and a video you're watching or a game you're playing. It's the gatekeeper, managing how and when applications access your computer's memory and processing power. And just like a maestro, it makes sure every note is hit at the right time, in the right order, for the right duration. So the next time you power on your computer and everything just works, remember, the answer to your computer's smooth operations lies in the operating system. Think of an operating system as the brain of your computer, but what does this brain do exactly? Well, let's dive into the fascinating world of operating systems to unravel the mystery. At its core, an operating system, or OS, is a software that serves as the intermediary between you, the user, and the computer's hardware. It's the silent maestro, conducting the symphony of processes that occur every time you interact with your device. So, what are the basic functions of an operating system? Let's break it down. Firstly, the OS is responsible for managing your computer's hardware resources. This includes overseeing the use of the central processing unit, memory, disk space, and peripheral devices like your keyboard and mouse. It's like a traffic cop, directing the flow of data and ensuring everything runs smoothly. Next, the operating system facilitates the user interface. Ever wondered how you're able to click on an icon and open a program? Or how you can drag and drop files into folders? That's all thanks to the OS. It translates your actions into commands that the hardware can understand, making your interactions with the computer intuitive and user-friendly. Finally, the OS oversees system performance and security. It ensures that software and applications run efficiently. It also safeguards your system against threats, maintaining the integrity of your data. Think of it as a vigilant sentinel, always on the lookout for anything that could disrupt the harmony of your system. So, in a nutshell, your operating system is a multitasking marvel. It's the unsung hero in the background, tirelessly working to provide you with a seamless computing experience. From managing your computer's memory to providing an interface for you to interact with your device, the operating system does it all. An operating system isn't a singular entity, it comprises several components that work together. Let's start with the kernel. The kernel is the heart of an operating system. It interacts directly with the hardware, managing resources and tasks. From handling memory allocation to managing input and output devices, the kernel is the bridge between your software and the hardware. Next up, we have system utilities. These are software tools that help manage, maintain, and control the operation of a computer system. They are like the backstage crew that keeps the show running smoothly. Disk cleanup, antivirus, and backup utilities are just a few examples of system utilities. They work silently in the background, ensuring the system is secure, optimizing performance, and providing an environment for other software to run. Then we have device drivers. These are specialized pieces of software that allow the operating system and other software to interact with hardware components. Think of them as translators, interpreting the language of the hardware for the operating system, and vice versa. Now let's talk about the shell. The shell is a user interface that allows humans to communicate with the kernel. It can be either a command line interface where you type commands or a graphical user interface where you interact with visual elements. Finally, we have application programs. These are the software applications you interact with daily, from your word processor to your web browser. They rely on the operating system to access the hardware and perform their tasks. All these components work together in harmony, creating a symphony of operations that enable you to interact with your device, run applications, and accomplish tasks. The kernel, system utilities, device drivers, the shell, and application programs each plays its part in the orchestra of an operating system. Each component of the operating system plays a vital role, ensuring your computer operates efficiently. Just as humans have a variety of brains, computers too have a variety of operating systems. Now let's delve into the different types of operating systems that bring these machines to life. Each type is unique, tailored to cater to specific needs and use cases. First up, we have batch processing operating systems. This is like a disciplined chef who prepares meals in large quantities, following one recipe at a time. In the same way, batch processing systems execute a series of programs or batches without manual intervention. They're excellent for tasks that don't need immediate user interaction like data analysis or long computations. Next in line are multitasking operating systems. Picture a juggler, effortlessly keeping multiple balls in the air. These systems work similarly, managing multiple tasks concurrently. They switch between tasks so rapidly, it appears as if all tasks are running simultaneously. This is how you can listen to music, browse the web, and write an email all at the same time on your personal computer. Then we have multi-user operating systems. Imagine a busy restaurant kitchen with multiple chefs all cooking at once. These systems allow multiple users to use system resources simultaneously. They're commonly found in network environments where many users need access to shared data and applications. Last but certainly not least, there are real-time operating systems. These are like an expert surgeon performing a critical operation where every second counts. They're designed to process data without any buffer period, making them ideal for time-critical applications like air traffic control or pacemakers. Each of these systems has its unique features and uses. Batch processing systems are great for tasks that can wait, while multitasking systems are perfect for personal computing. Multi-user systems shine in collaborative environments, and real-time systems are crucial when there's no room for delay. From smartphones to supercomputers, different types of operating systems cater to different needs. So the next time you switch on a device, take a moment to appreciate the operating system working tirelessly behind the scenes, making it all possible. So why do we need to understand operating systems, you may ask? Well, operating systems are crucial in the world of technology. They work as a bridge connecting the user and the computer hardware, making it possible for us to interact with our devices. For computer science students and IT professionals, understanding operating systems is key. When developing applications, it's essential to know how the operating system will interact with your software. This knowledge allows you to optimize your applications, ensuring they run smoothly and effectively. Likewise, if you're looking to improve system performance, a solid grasp of operating systems can help you identify bottlenecks and implement solutions. It's like being a detective, able to solve the mystery of why a system is running slowly or crashing. Operating systems knowledge is also critical when it comes to troubleshooting. It can help you diagnose and fix issues, reducing downtime and improving productivity. A deep understanding of operating systems can open new doors in the world of technology. We've traveled a long way in understanding the operating system, haven't we? Indeed, we dove into the enigma of operating systems, unveiling their mystery. We discovered that an operating system is not just a program, but the lifeblood of a computer. It's the software that manages hardware, allows applications to run, and provides an interface between users and the machine. We then moved on to dissect the operating system into its vital components. We talked about the kernel, the core of the operating system, which directly interacts with the hardware. We also learned about the shell, the outer layer that interacts with the users, and how it's the shell that makes an operating system user-friendly. We further explored device drivers, enabling the system to interact with peripheral devices and system utilities that help maintain and protect the computer. Our journey then took a turn to explore the different types of operating systems. We started with single tasking systems, which can run only one program at a time, then went on to multitasking systems, which can run multiple programs concurrently. We also discussed batch processing systems, which execute a series of jobs without manual intervention, and real-time systems, which are used in time-critical applications. Lastly, we emphasized the significance of operating systems. We realized how fundamental they are in the smooth functioning of our computers and other digital devices. They manage memory, process tasks, handle input and output, and provide a secure and efficient environment for the execution of programs. So, as we wrap up, remember that all the magic that happens on your computer screen, from clicking a file to playing a game, is made possible by the operating system. It's the heart and brain of your computer, orchestrating all hardware and software components, making all other functions possible. The more you understand about operating systems, the better you can appreciate the complexity and beauty of modern computing. So, Keep exploring. Keep learning. Remember, the operating system is the heart and brain of your computer, making all other functions possible.